Let's look at how all of this relates to function arguments and return values. Let's define a function at the REPL which appends a value to a list and prints the modified list. First a list, and then a function modify which appends to and prints the list. The function accepts a single formal argument named k. We call modify, passing our list m as the actual argument, which indeed prints the modified list with 4 elements. But what does our list reference outside the function now refer to? The list referred to by m has been modified because it is the selfsame list referred to by k inside the function. When we pass an object reference to a function, we're essentially assigning from the actual argument reference, in this case m, to the formal argument reference, in this case k. As we have seen, assignment causes the reference being assigned to refer to the same object as the reference being assigned from. This is exactly what's going on here. If you want a function to modify a copy of an object, it's the responsibility of the function to do the copying. Let's look at another example. First, a new list, f, that refers to the 3 elements. Then a function which replaces the list, which we now call with the actual argument f. This is much as we'd expect. However, what's the value of f? F still refers to the original unmodified list. This time, the function did not modify the object that was passed in. What's going on? Well, the object reference named f was assigned to the formal argument named g, so g and f did indeed refer to the same object, just as in the previous example. However, on the first line of the function, we reassigned the reference g to point to a newly constructed list 17, 28, 45, so within the function the reference to the original 14, 23, 37 list was overwritten, although the unmodified object itself was still pointed to by the f reference outside the function. So we've seen that it's quite possible to modify the objects through function argument references, but also possible to rebind the argument reference to new values. If you wanted to change the contents of the list and have the changes seen outside the function, you could modify the contents of the list like this. And indeed the contents of f have been modified. Function arguments are transferred by what is called pass-by-object reference. This means that the value of the reference is copied into the function argument, not the value of the referred object. No objects are copied. The return statement uses the same pass-by-object reference semantics as function arguments. We can demonstrate this simply by writing a simple function which returns its only argument. Creating an object such as a list and passing it through this simple function returns the very same object we passed in, showing that no copies of the list were made.